Hello everyone. Let's try to understand in this lecture what is an oxidizing agent and why K2Cr2O7 is considered as an oxidizing agent. For this, let's start by a simple notion, understanding a simple idea. What makes something as an oxidizing agent and what makes a particular compound a reducing agent? Very simple concept, but for a longer period of time, students do not bother on learning upon these things or probably are not taught. So let's try to first get our concept clear. What is an oxidizing agent? Agent means what? Someone who helps. Yes or no? Passport agent helps you to get a passport. So what does this oxidizing agent help? It helps in the process of oxidation. Now, if you have ever heard of something called as a redox reaction or reaction called oxidation and reduction, you might have heard oxidation is nothing but loss of electrons. Definitely, it is addition of oxygen, removal of hydrogen. But along with that, you need to remember that oxidation reactions primarily mean loss of electron from an element or compound. Correct? Now, what is oxidizing agent? Oxidizing agent is someone who helps oxidation reaction. If suppose in oxidation reaction there is loss of electron, oxidizing agent is going to help this reaction by gaining the lost electron. The electron that is lost over here, somebody needs to pick it up. Who picks it up? The agent, that is oxidizing agent. So oxidizing agent is the one who is going to pick up that lost electron. Okay. Now coming to the reducing agent. Again over here, agent means somebody who helps, a helper. And what does reducing agent help? Definitely reduction. Correct? Reducing agent helps the process of reduction. What is reduction? It's either gain of hydrogen, loss of oxygen, or in other words, it's also gain of electrons. Okay, please refer to the redox slides for this explanation. But these are some basic concepts that I want you all to remember for a good period of time. Okay, now this electron that needs to be gained, who is giving them? Who is giving the reduction process electron to be gained? That is the reducing agent. The reducing agent is going to lose electron, okay, or you can write it as lose electron rather than loss of electron. Reducing agent will lose electron. Reducing agent will lose electron in order to support the gain of electron of reduction process. So please keep it simple. The best way that generally I recommend students to remember it as, at least remember what is the meaning of oxidation and reduction reaction. Once you know that oxidation reaction means loss of electron and reduction means gains of electron, you will automatically understand the helper needs to do the opposite thing. So if there needs to be a loss of electron, helper would take that electron which is lost. If there needs to be gain of electron, helper would give that electron to them so that they can pick it up and gain in their reaction. Okay, now here we are very much into focusing the oxidizing agent part. Why? Because just now, a couple of minutes ago, I mentioned one important point. What makes K2Cr2O7, that is potassium dichromate, a good oxidizing agent? Oxidizing agent meaning somebody who can help oxidation reaction help oxidation reaction by gaining the lost electron. Gaining the lost electron. Okay, so over here K2Cr2O7 needs to gain one electron. Let's see. K2Cr2O7. It's nothing, but basically it is a subdivision part of Cr2O7 2 minus. For more information on dichromate and chromate ions, please refer the presentation and explanation I've uploaded before this lecture. This is a dichromate ion. I want you to check the oxidation state of this dichromate. Either you can check it in the K2Cr2O7 form, I have no problem with that, or the ionic form. Let's see the oxidation state of chromium in potassium dichromate. As I've already mentioned it, you need to just write the number of atoms to find the oxidation state. Here we want to find the oxidation state of chromium. Mind you, K2Cr2O7 has no charge written on them, so this becomes 0. This is oxygen, okay? Potassium has a charge of +1. We are yet to find chromium's charge. We know oxygen has a charge of -2. Okay, so it is +2 chromium, -14 is equals to 0. 2 chromium minus 12 is equals to 0. 2 chromium is equals to 12. And finally, we can see chromium in this particular compound. My bad, it should be 6. Okay, has an oxidation state of +6. Okay, so chromium in this particular potassium dichromate compound has an oxidation state of +6. Keep this in mind and let's discuss a little bit more on chromium. If you have ever gone through D block elements, you'll know that chromium is a transition element and it is given by the formula. Its atomic number happens to be 24. It's given by the configuration. It's given by the configuration of argon, which is 18. Okay, if you have seen this, 4s2, 3d4. I suggest you to go through electron configuration and off-bow slides for this explanation. This happens to be the electronic configuration of chromium, correct? So chromium, basically, if you see 2 plus 4, okay, 2 plus 4 has how many? 6 electrons for its combining capacity. So 6 is basically the maximum oxidation state that can be obtained or that can be obtained by chromium. Okay, +6 is the oxidation state, maximum oxidation state that can be obtained by chromium, right? In potassium dichromate that we just discussed, over there also, chromium's oxidation state was +6. So if you tally this out, this +6, this +6, what does it indicate? In potassium dichromate, chromium is at its maximum oxidation state. What do we mean by this? That means, that is, it cannot lose any more electrons. Okay, so it cannot have an oxidation state like +7, +8 by losing even more electrons. Therefore, what is the only thing that chromium can do? It can't lose any more electrons when we compare it with +6 oxidation state. It can't become +7. So what it can do, it can only gain electrons. Gain electrons. Please try to understand this. Chromium in potassium dichromate is at its maximum oxidation state capacity. Any further loss of electron means that chromium's oxidation state would shift to +7 +8, which is not at all possible by chromium. So if loss of electron is not possible, what does chromium do in potassium dichromate? It resorts to one amazing solution, that it focuses only on gain of electron. That's the reason why chromium in potassium dichromate cannot, I repeat, it cannot be a reducing agent. Why? Because it cannot further lose any electron, but only can be a very good oxidizing agent, so that it can gain electrons and come down to +5, +4, +3, +2, so on and so forth. If you have understood this, please do consider sharing it with your friends and help them understand the notion that why potassium dichromate is only a good oxidizing agent and why not a reducing agent. Signing off. Bye.